is about complex numbers. It is given that z equals square root of 3 plus I. Express z squared in the form r e to the I theta, the exponential form, using the principal argument. So it is best to start by drawing the Argand diagram of z. Minus root 3 plus 1, so it's gonna be minus root 3 plus 1. This is the complex number z. Now we need to find the modulus, the r, and the argument, or the theta. To find the modulus, if you look at this triangle, actually this is the triangle, so this length is root 3, length is root 3, and this length is 1. Of course we don't need the negative, it's just the length. So to find the hypotenuse or the modulus, we use Pythagoras, so we get 2. And to find this angle alpha, we can use trigonometry. If we use tangent, tangent alpha is opposite over adjacent. Use inverse tangent 1 over root 3, we get, use a calculator, we get pi over 6. We have to use radians. Now alpha is this angle. The argument is always from the positive real axis, so this is the theta. The argument is supposed to be from positive real axis, so from here we go anti-clockwise direction, so that's positive angle. So that's, the angle is, one straight line is 180 degrees or pi radians, so it is pi minus alpha, we get the theta. So again, this is the theta and this is the r. Alright, so we have z in exponential form. Now if we're finding z squared, just square both sides. This 2 is squared and this e to the power of 5 pi over 6i is squared. When you have power to a power, you multiply the powers, you multiply, you get 5 over 3 pi I. So look at the principal argument rule here. The theta is supposed to be between minus pi and pi. Now 5 over 3 pi is bigger than pi, so we cannot use this angle. So you have to use, so minus, okay, so 5 pi over 3 is 300 degrees, so it's around this. This is the angle. Now we cannot use angle bigger than pi, so we have to use, instead of we use positive 5 over 3 pi, we can use this negative angle. So to find the magnitude of this angle, just do, well, one full circle is 360 degrees or 2 pi minus 5 pi over 3. So we get this angle, which is pi over 3. Now since the direction is from positive real axis clockwise, this is negative angle, so this 5 pi over 3 is equivalent to minus pi over 3, and this is what we can use because of the principal argument rule here. Alright, so this is the final answer for z squared in exponential form. Now the next part is complex number omega is such that z squared omega is real. This is important, and the magnitude or the modulus of z squared over omega equals 12. So let's start with z squared over omega equals 12. When we divide complex numbers in exponential form, we simply divide the modulus and subtract the arguments. So in this case, because we're talking about the modulus of z squared, previously we know it is 4. From here we know the modulus of z squared is 4. So modulus of z squared is 4. The modulus of omega is, we don't know yet, we're gonna call it r. So if you rearrange, be careful here, the r is 1/3, it is not 3. Just use algebra a little. Now using the second information, z squared omega is real. If it is real, this means there is no imaginary component, so it's gotta be horizontal to the right here, positive real axis or negative real axis. So the angle or the argument or the theta can only be either 0 or pi. So the argument of z squared omega should be either 0 or pi. Now when we multiply complex numbers, again in exponential form, we add the arguments. So the argument of z squared plus the argument of omega. And from the previous part, we know the argument of z squared is 1/3 minus 1/3 pi. So now we can just add add 1/3 pi to both sides. So 1/3 pi we add to both sides. So on the left we have only argument omega, on the right, so here we add 1/3 pi, add 1/3 pi. So we have the two possible argument of omega, which is 1/3 pi and 4/3 pi. However, again 4/3 pi is greater than pi, and we have to use the principal argument here. We cannot use bigger than pi, so again instead of the positive 4/3 pi, we have to use this negative angle. To find the magnitude of this angle, just do 2 pi, 1 full circle, minus the green, so 2 pi minus 4/3 pi, we get 2/3 pi, but the direction is clockwise, so minus 2/3 pi. So for the final answer, we have two solutions, same modulus, but the arguments can be 1/3 pi or minus 2/3 pi. Two solutions. Alright, I'll see you again next time.